your site?
Okay, now we are recording. The one that we had this similar program to this last October, and that one is on our YouTube channel. So this will be, if you missed part of it or somebody you know wanted to attend but they couldn't, we'll put the recording of it on our YouTube channel, on the library's YouTube channel, hopefully tomorrow or Saturday. And I can email people who are registered when it's there too. Let's see here. Okay, so our presenters tonight are members of the Oakland Astronomy Club. The Oakland Astronomy Club meets in the Rochester area. They have been existing and meeting for the past 35 years. The club is a nonprofit organization of amateur astronomers who promote the enjoyment of astronomy through educational outreach at local community events and libraries like this, nature centers, and through monthly viewing at the Addison Oaks County Park telescope platform, which they have. They have, which in pandemic times, they can't really do as much, but in non-pandemic times, they would have educational presentations that are followed by club members sharing their telescopes and providing a magnified view of the night sky. So until eyepiece sharing is again possible, the club is sharing their passion for the night sky online, and they do have ways of doing that, which you will see in a few minutes. So we are very happy to have with us tonight 3 members of the Oakland Astronomy Club, John Penuto, Gary Dietz, and Tom Krosky. And they are going to share a fun evening about what's up in Waterford's February night sky. And if you do want to chat during the presentation, Tom, John, and Gary will take turns manning the chat window. So if you have a question, go ahead and put it in. They will respond to as many as they can. They might have some that they would say that they will talk about at the end of the program, when there'll be maybe more questions and answers at the end. But you can chat during the program as well. So now we are going to be hearing from John Penuto.
Thank you very much, Jean. I appreciate that lovely welcome. And thanks to the Waterford Public Library for having us. We appreciate the opportunity. So my name is John. My co-presenters are Gary and Tom. And with us in the audience tonight is another one of our club members, Dave Holt. Dave and Gary are both members of the Waterford community and both members of our club. So if you see Dave chiming in the chat window with some very erudite answers to questions, he's probably right. He's very, very good. We're all amateur astronomers, but we are seriously interested in astronomy. This photo is of our club's observing platform at Addison Oaks County Park, where in addition to our personal telescopes, we share with our guests the club's 17.5 and 14-inch telescopes. And as Jean said, we're looking forward to a post-COVID time when we can invite you to see the stars the way that we do. So if you'd like to be invited when it becomes possible to share eyepieces, just send us an email to outreach@oaklandastronomy.net and we'll let you know about planned club events. But tonight we are so pleased to have this opportunity to share the night sky with you online. Just 1 or 2 more housekeeping notes and then we'll get started. We're trying to keep things fun and informative, and one of the tools that we can use with this Zoom software is called a survey tool. So from time to time, Jean is going to post a survey question. She'll invite you to pick an answer, and then she'll share the group's responses. The survey is completely anonymous, so even if you have no idea about the question or the answer, just give us your first hunch. This is just for fun. So also, if you'd like to jot down any of the references that we cite during the presentation, feel free to do so. But don't worry if you miss one, we're going to summarize them at the end for you on the last slide. So you'll be able to cut them down then, or you should be able to go to our website, oaklandastronomy.net, and find them listed there on one of the pages.
Hey, John?
Yeah, go ahead, Gary.
I am hearing your voice kind of drop out. I don't know if you, Gene or Tom, are you hearing that too?
Yeah, it's going in and out. I don't know why.
I think if you just got a little closer, John.
Yeah, maybe that's all you need to do.
Okie dokie. How does that sound? Is that any better?
That is.
Yeah, it is.
Okie dokie. Well, thank you for pointing that out to me. So if you do have any questions that we don't answer for you at this presentation, or if you have a question anytime, you can feel free to just send us an email at outreach@oaklandastronomy.net, and we would love to hear from you. So other than that, you can just sit back and relax, and we're going to explore together what's up in Waterford's February night sky. So here's an overview of the topic we're going to touch on this evening. First thing we'd like to do is take a look back at NASA's bold landing of the Perseverance mission on Mars last week. I have a great video clip to share with you about this, and I think you'll really enjoy it. And after we look back, we're also going to look forward to the spring equinox, which occurs on March 20th, just about 3 short weeks from now. We'll share some fun images there about my favorite recipe called sunshine pie, and we'll look forward to our share of that sunshine pie getting bigger and bigger real soon. After that, Gary's going to use planetarium software to note which planets are visible tonight, as well as the bright stars, asterisms, and constellations that make this season such a magic time to be looking up. We're going to spend some extra time in the constellation Orion because it's pretty much everybody's favorite. Here, Tom is going to take us from the naked eye visible objects to objects only seen through binoculars or telescopes or cameras. Tom's going to share some of Orion's hidden treasures with cool pictures of its many nebulas. At the end, we'll answer any questions from the chat window that may need a lengthier response than just a few lines of text. And our goal tonight, as always, is to further your enjoyment of the night sky. We'd like you to feel comfortable enjoying the sights of the celestial neighborhood that we all live in, and we want to give you know-how to venture outside and feel successful when you look up and you find the planets, stars, and asterisms that are so amazing. So without further ado, let's get started.
John, you're still breaking up a little bit.
Oh, that's so disappointing. I've got my headset on and I'm holding it as close as I can to my mouth.
I'm wondering if that might be the issue, is the headset, but yeah.
Okay. All righty. Well, I will do the best I can. So I'm going to move it a little bit further away this time. Is it any different?
Yeah, it sounds fine now. I just every once in a while, just go ahead. We'll let you know.
Okie dokie. Well, let's get started. So the first thing we're going to do is we're going to look back to last week's successful landing of the Perseverance mission on Mars. And like everybody else, we'd like to give a big shout out to the women and men of NASA who, in their own words, concocted some really far out ideas about how to delicately and autonomously land a car-sized payload of roving scientific equipment safely on Mars, a scant 33 million miles away from Earth. I don't know if you're able to catch any videos of last week's Mars landing. Imagine the excitement of the technicians who had planned this mission for years and years when they saw video images, the same videos that we're about to enjoy, of their outrageous plan working flawlessly. From onboard cameras located on the descent modules, pointing both up and down, we're going to witness the landing event as if we were there as it happened. So I'm going to switch over to the video now. And when our video clip starts, time-wise, Perseverance has already separated from that cruise stage, the one that had guided the capsule for the past 7 months. We're at the point where the heat shield has done its job, slowed the spacecraft down from its 12,000 mile an hour entry speed to a still supersonic, nearly 1,000 miles an hour. And the audio on this recording is a little bit rough, but the video is absolutely fantastic. So here it goes.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
We're at the point where the heat shield has done its job, and now the parachute is about to be ejected. And in the right-hand panel, you can see in real time how fast it's going. And on the left one, it's 30% speed, so it's slow motion. You can see that it's actually the cannon that shoots off the top part of the parachute, and you can watch it unfurl. So the first milestone that we just heard them say was that they have jettisoned the extra weight that they had used to stabilize the spacecraft at initial entry. They call them ballast masses. They successfully jettisoned those, which of course they'd want to do prior to entering using the parachute. Now that parachute only weighs 100 pounds, and yet it's going to withstand 65,000 pounds of force. And in NASA's words, it is described as one heck of a neck-snapping 9 Gs.
Indicate chute deployed.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
So the parachute has worked, done its job. It started to slow the craft down. It's going about 233 miles an hour, and the heat shield has been jettisoned so that the radar can assess their altitude and velocity of the craft. I sure wish that heat shield that you can see down in the corner over here, I wish we could see it hit the surface, but the forward motion of the craft is not going to allow us to see that. No footage of the heat shield hitting the surface, but the first two of NASA's Easter eggs have been revealed. I understand there's more to come. Easter eggs, a hidden treat in a basket. So they get a secret message on the parachute. There's colored patterns in the parachute. They've been secretly inscribed with the phrase "Dare Mighty Things," which is the motto that the NASA Jet Propulsion Laboratories uses to describe what their work is. And also embedded in the message is the geographic coordinates for JPL. So to keep people interested, there's going to be more of these Easter eggs, I'm sure.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
You might have noticed that there's some icons down the bottom of the screen that are representing the stages as to what's going on. So right now, the terrain relative navigation is operational, which basically means that the onboard computers are comparing live video images to previously captured images, and they're making autonomous decisions to guide the payload towards a safe space in the targeted landing area.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
So the engines of the descent module have fired up preparation for separating the descent module from the parachute. And the descent speed is now about 185 miles per hour. And in just a few seconds, right up over here in the video, you're going to see a brief flash of light as the descent module actually separates. And then the video is going to show a sharp swing as the jetpack executes a planned, elusive, evasive maneuver to get out from underneath that parachute. And here we go.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
So the descent module is still plummeting, now at 167 miles an hour, just 3/5 of a mile from the surface of Mars. And it's time for that jetpack to kick into high gear and position itself vertically above the landing site. So it's going to throttle up to reach a stable hover point where it will be able to execute what they call the crane maneuver, which is how they're going to lower the rover.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
So right now we can see 3 of the cameras on board. And here the one on the right-hand panel is all the dust being kicked up from the rocket engines on the surface of Mars. And over here, I'm going to roll it forward just a little bit. Over here, we're looking up at the jet engine pack. I'm going to go just one hair more. There we go. We're looking up at the jet engine pack, and you can see these nylon ropes that are used to cart down here. You can see the rover being gently landed on the ground. Something particularly interesting that I could call your attention to are these rockets up here. As you can see, there's no flame, no fire coming out of those rockets. And you might wonder what the heck's going on. NASA explained that the rocket fuel that was used was something called hydrazine, and it's a reaction that gets produced not from combustion, but from a chemical reaction. And what happens is that chemical reaction produces a powerful gas jet of nitrogen and hydrogen, both of which are clear gases. So the plumes that we're expecting to see, the ones that we see them lighting up the ground over here or making the ground on, those plumes are indeed hot, but they're not flames, they're just clear gases.
Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touch.
So we'll freeze you right there, and the Mars orbiter that we just referenced, MRO, has been orbiting Mars since 2006, and it acts as a communications relay to confirm that the rover has landed. And if you see right here, you can see that the ropes were severed, the nylon ropes, and you can see that the module is now flying out of way.
Confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Well, I hope that you've enjoyed this amazing footage. NASA's mission chief, science mission chief Thomas Zurbuchen, has quipped about the video, saying that it's the closest you can get to landing on Mars without putting on a pressure suit yourself. So, well done, NASA. Just an amazing, amazing feat. So now let's return to our PowerPoint show.
Hey, John.
Yeah, go ahead, Gary.
Can you change your mic or take that off and use a different mic or your computer mic? It's still pretty bad.
Okay.
Yeah, it's almost gotten worse, I think.
Yeah.
Oh my goodness, what a disappointment. Okay, let me see if I can change that then to.
We could earlier we could hear you great, and
Now, you don't know if you're moving or if the mic is changing position around your mouth, but it's dropping out quite a bit.
I wonder if it's whatever this headset is that you're using, possibly.
Yeah.
Yeah. How's that? Is that any different?
It's a lot louder.
Gary?
It sounds good now. Let's hope it
Did that make any difference?
Yeah, it just needs to stay consistent is all. Go ahead.
Oh, come on. Gary, can you hear me now?
Yeah, you're fine.
Okie dokie. So we're going to put those away. Alrighty. Well, welcome to Jezreel Crater. I suspect there's going to be a high interest in this mission because one of the mission's primary goals is to find evidence of ancient microbial life in the seabed of this Jezreel crater that we're looking at here, which is a 30-mile wide crater that billions of years ago was filled with flowing water. You can actually see here where the water would have cascaded down in a river and then formed this delta here and filled this lake bed of this 30-mile wide crater as it flowed out the other end. So there was moving water there. So Gene, if you're ready, I would like you to post our survey question, and let's ask folks which way they're leaning. Let's find out if they think that the Perseverance mission will discover signs of ancient microbial life in Jezreel crater. Can you post that one for us, please? There we go. So it's a simple yes or no question. Tell us what you think. Back home on Earth, we've been enjoying a few lovely days of warmer weather and sunshine. And I understand that Mars is not quite as welcoming. Tom, can you help us visualize where Jezreel crater is on Mars? Maybe give us a clue about the temperature there right now?
Sure, John. First off, I'd say the Jezreel crater is about 18 degrees above the Mars equator. So as referenced here on Earth, the city of Waterford is roughly 42 degrees north of its equator. So Jezreel is much closer at 18 degrees. It's more like, say, Jamaica here on Earth, relative to the position to the equator. So at first glance, you might think being close to the equator implies warming, but Mars has very little atmosphere, and the atmosphere it does have is 95% carbon dioxide. So between little atmosphere, no clouds, no oceans to hold in the heat, it is very, very cold. And in fact, it ranges between -4 to -98 degrees Fahrenheit, and the average daily temperature is -81 degrees Fahrenheit. So it's a little nicer in Waterford.
A little cold for my taste. Thank you very much. Gene, have you got the results for us?
Yes, here's the results of the poll.
I think we're a pretty homogeneous group here.
Everyone thinks that there could be life.
Yeah. Well, I think they're going to find out one way or another. We're certainly a hopeful lot, aren't we? And patient, too, I hope, because this slow creeping of the rover and its rigorous scientific activities that are to follow are just not nearly as exciting as the landing was. But it's the answer to the question that's interesting. It's going to reveal something that we're all looking forward to know. The end game, of course, is to bring the evidence home to Earth for a thorough analysis, but I guess we're just going to have to wait to stay tuned. Well, that's the end of our look back at the successful landing of the Mars Perseverance mission. The next portion of our program is the looking forward part, where we're going to do a little science of our own. We spoke of summer temperatures on Mars just a moment ago, where it was a balmy -81 degrees below zero. So you did hear it right. It is cold, and Mars does have a summer season. In fact, Mars experiences all 4 seasons. The northern hemisphere of Mars just experienced its spring equinox on February the 7th. Well, that sure sounds familiar, doesn't it? On Earth, we're looking forward to spring too, just about 3 weeks away. So with both planets experiencing their spring equinoxes so close to each other, I think it's an opportune moment to do just a little science of our own and explain why, both on Earth and on Mars, we experience seasons at all. And we'll also hopefully clarify some of those odd words that are used to describe the new seasons, words like equinox and solstice. As we begin this next section of the program called Looking Forward to Spring, Gene, could we launch our second survey question? And here we're going to ask you to tell us what you think about the following statement. It's a true or false question. Seasons change as a planet's elliptical orbit brings it closer to or farther from the sun. Is that true or false? And we'll give you a few moments to think about your answer, but as you consider the question, it might help to look at the picture of where the inner planets are. And I don't know if you can see the picture with the survey question posted there. What the picture behind the survey question shows where the planets are relative to each other. And it's a snapshot I took just yesterday from a program called NASA's EYES. And I just like to mention it so that you can say you've heard it, and it's going to be in the reference or citation section at the end. It's just an amazing tool. It lets you see virtually anything in the solar system that you want to look at from any of the vantage points of satellites that we have launched since 1950 to the present. So it's free, absolutely free. You can either just play with the app on their website, or you can actually download the whole program for free. So, Gene, how are we doing with our answers?
Oh my goodness, it's been a minute. Okay, I'm going to end the polling.
Okay, and can you share the results so we can see them?
It's kind of 50-50 a little bit.
Well, that's good. So, sadly, I have fooled some of the people with that trick question, but we do have some people who are sharp and who are in the know that it's easy to imagine that the reason for the seasons would be that you're closer to the sun, so it's warmer, or you're farther from the sun, so it's colder. Absolutely reasonable. But surprisingly, Earth was actually closest to the sun on January the 2nd this year. And it's going to be farthest from the sun around the 4th of July. So go figure. So the elliptical orbits are not the answer to our question. The real reason that we experience seasons on Earth and on Mars is because of something called a tilted axis. Now we're going to explain very quickly what we mean by a tilted axis, but when we do, we're going to focus on our home planet, Earth, but the same explanation of seasons holds true for any planet with a tilted axis. So looking at this picture, if Earth's axis, well, first of all, we'll read the header. If Earth's axis were perpendicular to the sun, there would be no seasons. And I'm going to show you why in just a second here. So Earth's axis, what is it? It's an imaginary line. It runs from the North Pole to the South Pole. And in our imagination, we see that's how the Earth spins around. And as it turns one direction, we experience the day. And as it turns away from the sun, we experience night. So that rotation and that axis, it's just an imaginary line that we have posited here. But if things were this way, if the Earth's axis was indeed perpendicular like that, you can see pretty easily that there would be 12 hours of daylight, no matter which side of the equator you lived on. If you lived in the northern hemisphere or the southern hemisphere, you're completely bathed in sunlight for 12 hours. So it wouldn't matter whether you lived north or south of the equator, and there would be no seasons. But things are not this tidy. Earth's axis is not perpendicular, and on Earth it matters quite a bit which hemisphere you live in. So here's my picture of my recipe for sunshine pie. This picture depicts how Earth really turns on its axis. Here is the perpendicular line that we had hoped it would be, up and down like that, so it's like this to the sun, but it's not how it is. It's actually tilted 23.5 degrees. So here's the axis. It's not this, but it's this, okay? And that tilted axis always points towards the North Star, and it's the reason why we experience the seasons. That 23.5 degrees might have sounded like, so what? What's the big deal? But look at the resulting angle that we get when here's our line of night and day, and here's our equator, and here we are in wintertime, and here's our pieces of sunshine pi. In the daytime, it's pretty small, and at night, the pi piece is much bigger. So I think that it's something that we experience, and we know because we experience it. In the wintertime, we get less sun and we get more dark. But seeing this little graphic here with the light blue pieces of sunshine pi and the darker blue pieces of nighttime pi, I think is a great visual aid. I'd like to contrast that with what our experience is in the summertime. And as you can see here, the sun shines on our northern hemisphere. And the big piece of the pie above the equator is certainly the daylight pie, and the nighttime pie is much shorter. So we are looking forward to that bigger piece of summer sunshine pie, but there's more to say about that. The tilt of Earth's axis not only affects how we see the sun from season to season, but something that you may not have thought of is that it also affects how we see the moon. I don't know if you've noticed how high the moon is in the winter sky, but here's the graphic that explains why, and again, it's because of Earth's tilted axis. So here's our sun, and because of the tilted axis, the winter sun is below the horizon, so it's low in the sky. But look at it, it's just the opposite for the moon. It's actually above the equator, so it appears very high in our sky in the wintertime. And contrasting that quickly with the summertime, in the summertime, of course, the sun is above the equator, and so we get the sun is higher in the sky, and here in the summertime, the moon is actually below the equator, and that's why it looks lower in the sky. So it's the tilt of the Earth's axis that explains the seasons, where we experience the seasonal change of altitude of both the sun and the moon. So I don't know about you, but enough moon pie for me, and I'm ready for a bigger helping of sunshine pie. Now, it sounds odd to say this, but I'm going to say it anyway. All of the days between the solstices are just gradations along the path of more or less direct sunlight. So here's the two solstices in the summertime, and here it is in the wintertime. So in the wintertime, it's at its lowest point in the sky, the sun is, and then in the summertime, it's at its highest point. So what I'd like to share with you is, where did this odd name solstice come from? So on the solstice days, the sun is either stops climbing in the sky because it's got to its highest point, or in the winter solstice, it stops descending and they reverse directions. So solstice comes from a Latin word that literally means sun standing still. Sol is the word for sun. Sestite is the verb meaning stand still, hence the word solstice. So if you think about it, it's really a cool word. Summer solstice is when the sun stops climbing, and the winter solstice is when the sun stops descending. It seems to stand still and reverse direction. So other than giving us a pep talk about warmer days ahead, what is the real significance of the equinox? Equinoxes are special because for just 2 days a year, once in the spring and once in the fall, the tilt of Earth's axis is not a factor in how much light each hemisphere receives. And I think you can see that. It doesn't matter if you live north or south of the equator on that one day, and of course it's in the spring, it's the opposite direction, but each hemisphere is going to get the benefit of sunlight for a full 12 hours. So conversely, there's also going to be 12 hours of darkness. So hence the word equinox. The word equinox comes from Latin too, where equi means equal and nox means night. Equinox, another cool word. So equinoxes are unique days in their 50-50 split of day and night, and thus they mark the midpoint between the winter solstice and the summer solstice. But the spring equinox is still 3 weeks away, and there are some beautiful sights that await us tonight. As we move on to our next portion of the program, I'm reminded that science is one form of beauty, but even more beautiful is the experience of losing ourselves in the wonders of the night sky. Vincent van Gogh is quoted as saying, "For my part, I know nothing with any certainty, but the sight of the stars makes me dream." So I'm looking forward to this next segment of our program where Gary is going to paint tonight's sky for us using planetarium software. So Gary, what naked eye visible objects do you have in store for us tonight?
Thanks, John. One thing too, I think you might want to mute your microphone. John, I think there was an echo. Is that better now? Okay, let me go ahead. I will be showing you tonight's sky in Waterford, or really just the Oakland County area from our latitude and longitude, what it would look like tonight at 8 p.m. We use a planetarium program. It's called Stellarium. Let me share my screen here, and we'll begin to start looking. Can everybody see that? Okay, great. So in tonight's sky, we wanted to start with the planets. We're going to try and look at all of the things that are naked eye visible. When I'm done with that, then Tom is actually going to take you on a tour of some of the things in Orion that are not naked eye visible. Maybe one or two things that are, but then a number of others that are not that I think you'll find very interesting. But let's start out tonight, and we're going to start out with planets. And if we're in our southern sky, and I know the forecast earlier, I don't know if anybody's had a chance to look out, but they were saying tonight that starting around 7 p.m. and going for the remainder of the night, we were going to have clear skies. So there's a very good chance that you're going to have the opportunity to go outside and look. And that's really our ultimate goal here when we do these programs, is that we want you to be able to go out and do some practical things. If you have a telescope or some other viewing devices like binoculars, you can use those too. But we certainly want you to be able to go out and see and find a few things in the sky that you might not normally have done. So let's start out with planets. And the most visible planet right now in our night sky is Mars. And so if you go and look in the southern sky, and you can see I'm arranged right now in Stellarium, I'm looking in the southern sky in Stellarium. So if you went outside and you looked into the southern sky up at about 63 degrees, so 2/3 of the way up to the zenith, which is just the point straight overhead, you're going to find Mars, which is really probably at the southwest at 63 degrees. You're not, it's going to be hard to miss it because it's going to be one of the brighter things in the sky. There will be several potential things that you could mistake it for. And those are the two stars that are adjacent to it. Aldebaran, which is really the eye of Taurus the bull. And over a little bit farther to the left is Betelgeuse, which is the shoulder, or some people could call it the armpit of Orion the hunter. And all three of these are kind of in a row out in the sky tonight. You'll just have to remember that Mars is going to be the farthest right one. They all will have a little bit of a red or orange color to them. That's why it makes it a little bit difficult in the current season. Now, some of you may have seen Mars and Jupiter and Saturn back in the December timeframe, and these were all much bigger, much more prominent, and they were some really significant events that were happening at that time. Some of you may have seen the conjunction of Jupiter and Saturn, which was spectacular. I happened to have the fortune of being down in Florida at the end of December in the Florida Keys, and was able to see the conjunction of Jupiter and Saturn from down there, which was fantastic. We had beautiful clear skies, and I had my telescope with me, and it was just a beautiful thing to look at. But those two stars, Jupiter and Saturn, have now faded away, and they are actually not visible until real early in the morning. We'll say around 6:30. And I'll show you some photos of those in a moment. But let's first take a look at Mars. I'm going to move the sky over a little bit. And again, remember, if I'm looking into this south or southwest area, it's about 63 degrees above the horizon. And let's zoom in on Mars just really quickly and see a little bit more detail on it. You wouldn't be able to see this with the naked eye by any means, but I thought it would be interesting to take a quick look at what Mars does look like, and actually several of the moons of Mars. And of course, John was just showing you the photos of the Perseverance lander that just landed on Mars. But here's a close-up photo of it, and there are two moons. Mars has two moons, Deimos and Phobos, and these are both considered the sons of Ares or Mars. Ares in Greek and Mars in Roman, and the god of war, more or less. And Deimos and Phobos mean fear and dread or terror, and probably rightful names for the god of war. But Mars has two moons, Phobos and Deimos. So that's the most visible planet and most accessible for us to look at right now. You should be able to go out there this evening, even right now, and look in that southern sky, as I was showing you here, or southwestern sky, and see that up at about 63 degrees. This is the zenith right here. That's what the Z is. That would mean that's directly overhead. So you can see that when I look at this from the ground up to the zenith, we're looking, up at around, it's about 63 degrees at 8 o'clock. If you wanted to see Jupiter and Saturn, let me go to 6:30 tomorrow morning. I'm changing my time on my my chart here. Can't get too late because then it's daylight, right? I think the sun rises right around 6:30 or 7 o'clock. But here is our, if we can get them to come up here. Here they are over here, coming up just over the kind of the southeastern horizon at about 6:25, 6:30 in the morning. So it's very close to the horizon. It'd be difficult to see if you live near hills or trees or buildings or something like that, as well as if it wasn't clear out. Although they're saying it's supposed to be fairly clear all the way through tomorrow. But you can see here we have Mercury, Jupiter, and Saturn all coming up over the horizon in the southeast. And a couple of things. I just wanted to quickly touch on Jupiter and Saturn. Now, we said that Mars had two moons, which is, oops, that's Mercury, sorry. I wanted Jupiter. Mars had two moons, and we normally see about 4 moons of Jupiter. You can see them right here. This is Jupiter as I'm zooming in, and you can see 4 of the moons here. We have Ganymede, Europa, Io, and Callisto, and it looks like another one popping out there too, which is Metis and Almathea. But we typically see the 4, and Ganymede and is one of the largest in our solar system. It's actually as large as the planet, or larger than the planet Mercury. One of the interesting facts about Jupiter is, while we see these 4 moons, Jupiter actually has 79 moons. It's an incredible number of them. They're certainly a lot smaller than these 4, which we can even see with our telescopes when we take them out. But it has 79. Fascinating thing. Now let's zoom out, and I want to do the same thing with Saturn real quick, and then we'll move on. But let's take a look at Saturn. And we're going to zoom in on that. Of course, the unique feature of Saturn is its rings. But it also has 3 or 4 moons that are typically visible with our telescopes again. We can see a whole bunch of them here tonight. This would be the actual orientation of Saturn if we were looking at it in the telescope tonight too. But there's a whole host of different moons here: Dion, Enceladus, Tethys, Rhea, Titan. And Titan is one of the, also, I think it's the 2nd largest moon in the solar system, only to Ganymede. And it again is larger than the planet Mercury. But it's a moon because it's essentially caught in a gravitational orbit around Saturn. But the other interesting thing about Saturn is, while it is not the largest planet, and both it and Jupiter are what we call gas giants because they're mostly gaseous planets with a hard core interior, Saturn has 81 moons. So it's the 2nd largest, but it actually has the most moons. So it has 81 and Saturn has 79, and Mars, as we said, had 2, and Earth has 1, right? So another interesting thing. So again, if you wanted to see these, they're going to be more visible as we get more towards the summer, but you will be able to catch them if you're lucky to early in the morning around 6:30. It's going to be dark, getting light around 7 or so. So after that you won't be able to see it for a while. It won't become a visible night object for quite some time. But let's go back to our 8 o'clock on February 25th tonight. And we'll go back down and look at one thing we would be remiss, I think, in not taking a quick look at, which is visible with our naked eye, is our moon. Our moon. The moon would be approximately, I think, about 30 degrees above the horizon, and it's going to be almost due east. So as we saw over here, our Mars is going to be more over in the southwestern area. This will be almost due east. So you'll be able to look to the left and see the moon over here. This is about 63 degrees. This is probably about 30 maybe. And our moon tonight happens to also be at 97% illumination, which means it's basically a full moon. And really, for a lot of us astronomers that like to get outside and look at deep sky objects, which Tom is going to be showing you some in a little bit here that are absolutely just beautiful. I think one of the problems with seeing a full moon is it's like a big light bulb out in the sky, and it washes out a lot of the other objects that you want to see. So typically best viewing for us is what we call new moon, which basically means there's no moon, there's no illumination at all from the moon. It's being blocked by, the sun is being blocked by the earth, and we don't see any of it. So we get more dark sky and can see more of the objects out there. So the next thing I want to talk about are stars themselves and what the brightness of the stars are. We tend to think of the brighter a star, maybe the bigger it is, and that's not the case all the time. It is actually a function of that, as well as the distance it has from us, and basically how close it might be. One of the early Greek astronomers by the name of Hipparchus was the one that came up with the scaling system that we use today for determining the brightness of a star. And interestingly enough, he ranked the brightest stars as magnitude 1, and the next lower brightness would be 2, and so on and so forth. And as far as he could get with the naked eye, which was several thousand years ago, would be what he called a 6th magnitude star. So that he was able to notice with just the naked eye 6 different variations in the brightness of stars, and came up with this scale. Tom he's gonna I think be able to show us some of the ones maybe in Orion and some around Orion that potentially are different scales and beyond what we'd be able to see with the naked eye again. I think we have a question here too, Gene, on magnitude of stars. I wonder if you could pull that up.
Oops, let me unmute myself. Let's see here.
So what we wanted to know, well, that's
Wait, hold on. Sorry.
no problem.
Let me try again.
I think it's the magnitude.
Oh, crud. What? Just a minute. My goodness.
Technology's not cooperating here, huh?
I know, we're not. Why does it keep going to?
Well, Gene, if you let me answer this again, maybe I'll get it right this time.
Well, I'll tell you what, I will just ask the question.
Wait. I think I got it. Sorry. Hold on. Okay. Finally.
There it is. So we want to know how many magnitude 1 stars. Remember, that was the brightest one that Hipparchus was able to see. But how many of these do you think you can see from your backyard over the course of a year? Do you think there's 16, 56, 116, 100, 1,016, or more than that? How many number 1s are out there? So go ahead and put your answers in, and let's see what everybody thinks.
So the magnitude 1 is the brightest, right?
Correct.
So Gary, do you want to give us a hint, maybe what a magnitude 1 star might be, like Rigel or?
Yeah, Rigel, Sirius, which is the brightest star in the sky right now. We'll look at that in just a second, and maybe you'll show us some of those later. I mean, obviously these are naked eye visible, since they are the brightest ones out there.
Well,
I think we can go ahead and
I will stop this.
tally them. So we see 16 and 56. And then we had 3 people that voted for more than 1,000. So the correct answer actually is 16.
Whoops.
Yeah, there's a lot of stars that might be visible, but they're not all magnitude 1, the brightest ones in the sky. We'll show you some of those in just a second. But tonight we're going to primarily look at 7 of those. And I want to show you some of those right now. First, we want to look at some of the different stars in asterisms. And the 6 stars that are in this, basically these are asterisms here, what I've highlighted on the screen. Can you see that?
Yep.
And the asterism that there's 2 primary ones here that I'm showing. One is the winter triangle here, and the second one is the winter hexagon. And within this winter triangle and winter hexagon are actually 7 of the brightest stars in the sky for tonight. So this is in the southeast, and this is quite large. You can see that this is looking straight overhead again. That's the zenith. So this winter hexagon goes almost probably from 20 degrees all the way up to the zenith. It's a huge asterism, and the 6 stars that are in it are Capella. Over here, this one is Pollux, which is one of the twin stars of Gemini. Procyon, Sirius, Rigel, which is one of the stars in the Orion Nebula, or the Orion constellation, and then Aldebaran. Again, I mentioned that was the eye of the bull of Taurus. And so those 6 stars form what's called the winter hexagon. And the 3 that form the winter triangle are Procyon, Betelgeuse, and Sirius. So I think maybe we could use a little bit of a definition of what a asterism is versus a constellation. Tom, would you be able to help us out with that?
Sure. A constellation typically is a group of stars that form a specific image in the sky. And sometimes, admittedly, you have to have a vivid imagination to see these images. And constellations actually have been officially cataloged into catalogs and are specific areas in the sky as well. Whereas an asterism is, and there's some of those images, thank you. Whereas an asterism is just a more common picture of several stars, like a triangle or a hexagon, et cetera. So it's typically a subset of a constellation.
Thanks. So, and I think to highlight just what he said, I wanted to show you some of these pictures. Whereas, and the Big Dipper is actually it's an asterism. The constellation is actually the bear, the large bear, and the small bear of what we would traditionally or what the Greeks and all would traditionally have seen in the sky here. You have in the winter hexagon, you can see it actually spans a number of different constellations, and put the labels in here. So you can see that Ursa Major being the actual constellation for the Big Dipper, the winter hexagon again covers Taurus the bull, Auriga, Gemini the twins, Monoceros, Lepus, Canis Major. So it spans a number of those, but by connecting all of those 6 bright stars, you get that asterism. So I thought this traditionally, these images here are typically Western. These came primarily from the Greeks and the Mesopotamians. If you were Chinese or you were another culture, you would have a completely different set of images that you would see in the sky, or that you used in your culture to identify and categorize and group these stars in the sky. So we all had different ones, and these are just happened to be the ones that were primarily Greek and Western. Gene, I think we do have another question here too. I think it's on the number of constellations. That was the previous one, so it's the next one. Yeah, there we go. So how many constellations are there in the whole sky, northern and southern hemispheres combined? Do we think there's maybe 22, 44, 88, or all the way up to maybe 352? So how many constellations do you think there are? Everybody please vote.
I think everyone has voted who's going to vote, it looks like.
Okay.
It's rather, again, rather equally spread out.
Let's see. We see 22. Nobody voted for that. We have 3 for 44, 2 for 88, 2 for 176. So in the northern and southern hemispheres combined, believe it or not, there are 88. So 2 out of the group got those. And the interesting thing that we know about the constellations is in early times, they only identified with about 44 constellations, which is in some ways a little bit of a trick answer there, a trick question, because the 44 that they could see were only visible from the northern hemisphere. And that's where most of the people live on Earth, is in the northern hemisphere. And most of them had never gone, and they didn't have a way to go to the southern hemisphere to view all of those other constellations and stars. And so the outer space at that time was only 44. But as they were able to travel and as they were able to go around the world and be able to see the sky from all of these different regions in South America and Africa and around Antarctica, they saw all of the other all the other constellations and were able to name or create a number more of them. And actually, I think it was in 1929, the International Astronomy Union was formed and created 88 formal constellations for the sky, or regions of the sky. And so those now are official for how you group and look at the different constellations and identify them. So those were not done. That was not done though until around the 1929 timeframe. So the 7 stars out of the 16 that we were talking about tonight that are magnitude 1 are again the ones in the hexagon and the ones in the winter triangle: Capella, Pollux, Procyon, Sirius, Rigel, Aldebaran, and then in the middle of the hexagon, or one of the corners of the triangle, is Betelgeuse, which is one of the constellation, or the parts of Orion. You can see Orion right here. We'll turn off the asterisms and I'll show you the constellation lines real quick. So now you can see Orion, the belt, and that's where I think I'm going to hand it off to Tom, who's going to talk to us now about some of the fun things inside of Orion and some of the deep sky objects that you can't see with the naked eye. Tom, I'll stop sharing and hand it off to you.
Okay, thanks, Gary. Can you see my screen?
Not yet.
Okay, we got you now, Tom.
Yep.
All right, I'm just waiting it to go to slideshow here.
Alrighty.
Okay. Well, as Gary said, I'm going to talk about some of the hidden treasures, those that are a little bit harder to see, especially when there's such a bright moon out, as Gary talked about. And these are deep sky objects in the Orion constellation. And you may be wondering what a deep sky object is. It's basically objects in the sky, anything other than single or double stars. So it's things like star clusters, nebula, or galaxies. And these really became popular in the 1940s with the availability of more affordable telescopes. And there was a very popular column written in Sky and Telescope called Deep Sky Wonders by Walter Scott Houston, who came up with this concept of hidden gems and deep sky wonders. And basically, there are catalogs of objects in the sky, and by far, to amateur astronomers, the most famous catalog is the Messier catalog, and it shows the relative more brighter objects. Admittedly, they're dim to start with, but these are objects that you can see with a pair of binoculars, with a smaller telescope, and many with even your naked eye. It's just with the naked eye, you will not be able to see the level of detail that you could if you were using binoculars or a telescope. So Charles Messier was born in 1730, and he was a famous comet hunter, and his interest in astronomy really grew when he was a young teenager. He actually observed the Great Six-Tailed Comet of 1744, and this was a comet. Of course, there's no pictures of it because there was no cameras in 1744, but there are drawings where it was a comet that actually had 6 distinct tails that you could see, and it was very, very bright in the sky. And also then 4 years later, with Messier living in Paris, there was a total solar eclipse in 1748. So between these two events, it really triggered his mind, his imagination, and he decided that he wanted to become an astronomer. So he studied astronomy, and in 1751, he went to work for Joseph Delisle. And Mr. Delisle was the royal astronomer for the French Navy. And this is a very important position because, of course, the Navy would need stars that were adequately charted to which to navigate from. So Messier worked for Joseph Delisle, and during this time, he started to observe a lot of objects. The first thing that he plotted was the Mercury transit of 1753. And he was working actually out of a hotel in Paris, Hotel Cluny. And they have an observatory in one of the towers there. And he did not actually discover all of these objects, but you can see in this picture here, there's 110 objects that have eventually been cataloged to his credit. And he was using a smaller scope. Many times he used just a 4-inch scope. And he was looking for comets, and he kept finding these, quote, fuzzy objects. And when you're looking for a comet, it typically from night to night will move its apparent position relative to other stars each night. It would move a little bit. But these fuzzy objects that he kept finding would not move. And then he would know that this couldn't be a comet. And quite frankly, at first he was not cataloging them, and he might find them a year later and realize, hey, I've already found this item. So he decided to create a list or a catalog. The first one was M, but labeled M1 for Messier 1. It was actually the Crab Nebula. And he published his first catalog in 1771 with 45 objects. And this became so popular with other astronomers that it actually got him to start thinking about, I should be, looking to catalog all of these fuzzy objects as much as I'm looking for comets. So throughout time, he cataloged up to 103 objects. Now, I should mention, and this final catalog that he published was in 1784, but he, much like he was an assistant for Mr. Delisle, he had an assistant named Pierre McCain. And McCain actually found 30 of the objects out of these 110. Messier found roughly 40 of them. And the balance were actually discovered by other astronomers, some as early as 1000 BC. Hesiod, a Greek astronomer, and discovered or cataloged M45, which is the Pleiades, which is an open star cluster. So after publishing this final catalog in 1784, other astronomers have found documents that showed that Messier actually had listed and cataloged some other 7 objects, but for whatever reason, they were not in the initial catalog, but they've been subsequently added. So any amateur astronomer basically will use this catalog more than any other catalog for looking for these deep sky objects, because you can find them much easier than many of the other deep sky objects. When you're looking at nebula, there's basically 5 types of nebula. The 3 on the top are by far the most prevalent and popular. The first one on the left here is called an Emission Nebula, and then you have a reflection nebula and planetary. And Emission Nebula is where the nebula itself is actually emitting light that you can see. It's generating light photons, whereas a reflection nebula is not emitting light. It's basically dust reflecting light from other stars. And then finally, the planetary nebula is caused by a star starting to contract and generating electrons that are hitting expelled gas from these stars. I said a planet, but it's really coming from a star. The electrons are being generated by a star collapsing and then exciting the light, causing these the gas around it to emit light. So beyond these 3 popular nebula, there's 2 others: dark nebula and supernova remnants. Nebula basically is a Latin term coming from mist, vapor, fog, or smoke, and it's basically just shining molecules of dust or gas, except for the dark nebula. And the last thing I'd say is all these nebulas are within our own galaxy, the Milky Way. When you look out of the night sky, it is also possible using binoculars and telescopes to see other galaxies. And in fact, it's possible to see with the naked eye another galaxy. It's object M31, the Andromeda galaxy. But if you see it naked eye, you have to have very good eyesight. You have to be in a very dark, moonless night, no light pollution, and it will look very, very fuzzy. It will not look like a picture of a galaxy that you typically see. So where are these hidden treasures in Orion, the constellation? This is the same constellation Gary was showing you. And basically I've got them numbered, and you can see 3 of them are pretty close to the star Alnitak. And then I'll show you the Witch's Head Nebula off next to Rigel. And then I'll finish up showing Orion's Nebula. And it's the easiest one to see. And, you know, at the end here, we're actually going to challenge you to try to some night try to find that yourself. So here's the first one, Casper, the friendly ghost. It's a reflection nebula. It's about 1,600 light years away. It's very small. It's only 1/10 of a degree by 1/10 of a degree. And you may wonder how big a degree is, but a common way to approximate what a degree is, if you hold your arm out and you look at a finger or your thumb, that equates to about 1 degree. So if you were to line, let's say, your thumb up next to each other and go all the way around the sky, you'd have 360 degrees all the way around the sky. So that gives you an idea roughly how, you know, large these things are. So at 1/10 of 1 degree, Casper here is very, very small. And you're looking at this object here. This is actually 4 nebula. This large first one is Casper, and these are 3 other nebulas. You may be going, a little difficult to see the ghost. And I will say, whether we're talking about what constellation art looks like or what these nebulas look like, you sometimes need a pretty active imagination. But really, you can see the ghost in 2 ways in this picture. In this larger object, if you picture this as kind of a sheet over a ghost per se, and these are the corners that you could see, you know, almost I'll call it like a Pac-Man type of ghost. And then also the other way to, or a different way to look at a ghost is almost looking at a ghost here of a, you know, a creature where you have the head right here and then the arm sticking out in the body. So really two ways of, you know, looking at this object. And as I mentioned, there's really no way to see this other than with, you know, telescopes or through images. So this next object is the Flame Nebula. It's an emission nebula. It's about 1,350 light years away. It's much larger. It's 2 degrees by 2 degrees. That's fairly large, but it's well, it looks bright here. It's actually fairly faint. It's a 10th magnitude. As Gary said many years ago, in a very dark sky, the best you could see was down to 6. So 10 is quite a bit dimmer than 6. And it's not an equal scale, it's a logarithmic scale. So while it is larger at 2 by 2 degrees, it is dimmer. And so this is the star Alnitak, and you can see, you know, how much light it's throwing out. It's actually bloating the star. And it is possible to see this very faintly with powerful binoculars in the dark sky, but there's no way you'd see it naked eye. The next image then is the Horsehead Nebula. This nebula is, I would say, in the top 5 of popularity for amateur astronomers to try to see. It's actually a dark nebula, and really what you're looking at is almost 3 nebulas here, and the large background is basically a hydrogen generated ionized gas nebula, and this Horsehead is actually dark dust that's blocking the nebulosity behind it, that allows you to see the dust. And lastly, down here is you know, another emission nebula. So this object is about 1,500 light years away. It is about 1 degree by 1/10 of a degree, and it is about at a 7 magnitude, but it is very, very difficult to see. And I would say the same thing, you know, you can see these in telescopes, but even in a small scope, it is really hard to find unless you're in a very moonless night without, you know, light pollution. But it is very popular for imagers to take pictures of it. And in fact, this next picture is an amateur picture here, and it combines both the Flame Nebula and Horsehead Nebula. It's in black and white, and you can see all the nebulosity here behind the Horsehead Nebula, and then here's Alnitak. And the centers of these, the Flame and the Horsehead, are about 4 degrees apart. And if you use a parallax to try to calculate, if I did my calculations right, the center of these two would be about 600 light years apart. So fairly far apart. Next object is the Witch's Head Nebula. And I've got 2 pictures of this. And just to describe, the first one I think shows a little bit better. Once again, you need a little bit of imagination, but here's the witch's nose. The witch has mouth open, yelling, the chin, kind of the eye socket, and the forehead, right? And this nebula is a reflection nebula, and it's very large. It's 1 degree by 3 degrees. And I think this next picture actually does a better job kind of explaining what's happening here. And this is Rigel the Star. And you can see it's basically shedding a lot of light that's reflecting off the witch's head dust molecules that are reflecting the light. And you probably, you know, I said this witch's head is about 1,000 light years away. And, you know, I really haven't explained how far a light year is, but a light year is how far light travels, and it will travel about 5.9 trillion miles in 1 year. So given that it's 1,000 light years away, that says it's 5.9 quadrillion miles away from Earth, or 5.9 with 15 zeros behind it. And just to put that in perspective, John was talking about Perseverance, and it was traveling to Mars at 12,000 miles an hour. So to travel to the Witch's Head, the Perseverance modules would take 56 million years roughly to get there. So just huge, vast distances out to these objects. Okay, the next object is probably the most popular nebula in the sky, and then clearly in the northern hemisphere anyway, and it's the Great Orion Nebula M42. It's an emission nebula. It's about 1,350 light years away. It's fairly large at about 1.5 times 1 degree in diameter, and it's 4th magnitude. So it is considerably brighter, and hence why we will ask you to try to find this some night in the sky. And this image here was taken by a member of a club. A 4-inch refractor was used, you know, a smaller scope compared to most Newtonians or Schmidt-Cassegrains or Dobsonian telescopes. A Canon DSLR camera was used. And, you know, in this picture, you can see a lot of the dust lanes or the nebulosity. There's actually, this is called the trapezium, and there's actually 5 brighter stars here that are making all this light. And actually in this trapezium region, there's actually estimated to be over 700 stars being formed. So it's a very popular area to research by scientists to try to understand star formation. It's one of the closest regions in the sky that's forming these new stars, and that's what's illuminating and emitting a lot of the gas and the light that you can see. So how would you find the Orion Nebula? So if you start with the constellation Orion, here's Orion's belt. Here's Alnitak, where some of these other nebulas were. But in the sheath or in the sward, actually what looks to be the middle star here is the Orion Nebula. It's actually the bright areas, these the trapezium, these 5 stars. And going back to this picture and kind of turning it on its side, these are those 3 bright stars, I will call them, in the sheath or the sword of Orion. And so this top one actually is the new Orion variable star. There's also some nebulosity around it. This then is the trapezium. And then this is Hatza, which is also called the lost jewel of Orion. So if you look basically at this with your naked eye or even a pair of binoculars, you should be able to see something. And this next picture really shows more what it looks like non-magnified through a telescope. And so here is the constellation Orion. Here's Betelgeuse, the orangish, yellowish, brighter star in the sky. Here is the belt of Orion, and here's the solar sheath. And you can see in this picture a little bit of nebulosity. And I will say it's very hard to see in a metropolitan area with the sky pollution. I happen to live in Rochester. I've never been able to see the nebulosity naked eye, but on a dark moonless night, I've taken out a pair of binoculars and been able to see it. So you'll be able to find it clearly naked eye, but seeing some of the nebulosity like you see in this picture probably will require some binoculars. And they don't have to be, big binoculars, but if you go up north, I know when I've been up north, I've actually have seen it naked eye. So our challenge, this is kind of our last picture slide per se, but our challenge as a club to you is to, in the next clear night, try to find it and either, use your naked eye or ideally pull out a pair of binoculars and see if you can see some nebulosity. I doubt if you could see nebulosity tonight because it's near a full moon, but on a moonless night or one that's just has a small crescent moon, there's a chance that you'd be able to see the nebulosity. Okay, so with that, we're going to open it up for questions on nebulas or really on any of the topics that John or Gary have covered or anything else. Just put them in the chat. And if you think about something later, or if you want to join one of our regular meetings, you can always email us at the address that we've got there. Okay, so.
Okay. Tom, I'm looking in the chat window right now, and there's no unanswered questions currently in there.
Okay.
So we'll give them just a second to see if anybody posts anything new, and then maybe we'll just move on to our last slide where we show all the citations that we had said we'd show people before we wrap up. But that was a really nice presentation. I'm particularly interested in being able to see M42 or the Sword of Orion with some binoculars. I'm going to try tonight because it's supposed to be pretty decent out tonight. So I'm going to have a go at it. Anyhow, so if you want to stop sharing your screen, and I will start here where we left off before we went to see Gary. And here was the list of references that we said that we would put together for you. Here's, of course, is our club website. And on the observation tab there's going to be a citation page, and you'll be able to see all of these notes here, as well as some notes about the February sky. And if you have a question, please feel free to just send us an email, or if you'd like to join our mailing list, we would very much like to hear from you with any questions or just to let you know when we're doing something. We had one question in the chat. What was the program that Gary was using? And there it is, stellarium.org. And there are some other programs that are of interest oftentimes as well. The one that we used today was the Astronomy Picture of the Day from NASA. We talked about the eyes.nasa.gov. So there's a couple of really great places to go. And Gary, if you talk for just a minute about some of those free apps or the library books, I'd appreciate it.
Yeah, and so another one of these little helpful things that you can do to go out and find some of these objects. And again, what we want you to do is get outside and try to find some of the things that we talked to you about tonight. But there are some apps that you can get for your smartphone, and there's a few of them there. You can see Sky Portal. I use Skyview and Redshift. I think, John, you might use Sky Portal, and Tom might have Skywalker, a couple of the other ones there. But there's a number, even these aren't even all of them. There's quite a few of them. These are just the ones that we use and that we find are very useful, and most of them are free. Or the most that you'd have to spend would be maybe $1 or $2. But I think I've gotten mine for free, and they're just amazing power in these things where you can just point your smartphone at the sky, and it tells you all the different constellations, the stars, even some of the man-made satellites and rockets and things that are up in the sky. It'll even point those out. Another one that is a favorite of mine that I never get tired of is the ISS Spotter, which is the International Space Station Spotter. And again, it's just a free app from NASA. You put it on your phone, and it'll let you know, it'll alert you as to when the space station will be coming overhead in your area, tell you where to go out and look and what time. And absolutely never gets old to me to see that going over. A couple of the books there, which are some of the go-to books, even for us more experienced people, like H.A. Ray's The Stars and Finding the Constellations. They're simple, easy books to follow. They're not going to overwhelm you with a lot of techie talk. They're pretty much made for the average person, and very informative, and again, allows you to get outside and start looking at things right away. So I highly recommend any of those that if you could go out and purchase. But
And I did check all those books out, and they are all available from your local library here. You may recognize H.A. Ray from the Curious George series for kids, but H.A. Ray was also a very serious amateur astronomer, and his books are even used to teach college courses on astronomy, so they're worthwhile. So with that, there's the end of our show, and we'd like to thank you for spending your evening with us, and I apologize for any of our audio issues that we had. I hope we were able to at least make you feel comfortable with looking at the night sky and finding things for yourself.
Yeah. Thank you. Thank you, John, Gary, and Tom. You might be amateur astronomers, but you have a lot of knowledge.
Well, thank you very much. And one final note, if anybody has interest and would like to join one of our monthly club meetings, they're online and they're pretty much like what we just did tonight. We'll talk about an interesting topic and we'll share information back and forth. So if you'd like to just come to a meeting as a little mouse in the corner and just watch what we do, you're awfully welcome. We'd love to have you come. Just check out our website there, oaklandastronomy.net, and you'll get an invitation to come to one of our meetings. So in the meantime, stay safe, look up in wonder, and we wish you clear skies and a good night.
Great. Thank you.
Thanks,
Thank you
Gene.
so much. I'm gonna end the program, and thank you to everyone who attended as well.
Hey, thanks, Gene, for hosting.
Yeah.